Hello guys, my name is Andres and I'm here to help you guys with question number 7. It says to consider the following demand figures for the 7 most recent periods, and it says to compute the forecast for the next period using the methods indicated below. So what we could do is to organize ourselves is to make a linear trend chart that it will consist of the slope, the intercept, the absolute error, the squared error, and the absolute percentage error. Now, as basic algebra, we know what the formula to slope is. It's y equals mx plus b. Um, so we'll click the formula slope, and Excel could find that for us. Now it says it's asking for the known y's and the known x's. When we go here, normally when you look at a chart, you could tell that on the bottom, which is x, it's the independent variable. It would be the time-based variable. So let's do for it. It is asking first for the y, meaning if the period is the x, the independent variable, then demand would be the dependent variable. So this would be the demand, right? And then also for the x, it would be the and then it would be the B5 to B11 for our y's, and then we would click comma to now put our independent variable, which our x is the period time 1 through 7, and we would just click enter. That would be our slope. Our slope would be how the line is on the graph at what rate it's going. So it's going at a 3.39 slope. Yes, now to find our our interest rates, our intercept. It's late in the day, guys. I'm sorry. So to find our intercept, we would have to same thing as a slope. Excel can do it for us. We will click intercept, and it says to select our y's, which is the demand, comma, select our x's, which is the period of time, and enter. So our intercept will be at 30. I'm guessing at 30, the demand at 30.42. So now our next thing is actually to get our linear trend. We'll start off with the first one as basic algebra equation. Probably the most important one that you should always remember is the y equals mx plus b. So we'll click equals. So what is m? M is actually the slope. So we would click on here. Let's make sure we anchor down that cell with the dollar signs. And dollar sign. Okay. So it's the slope times x. So we will multiply with the x, which is our independent variable, the 1 period of time. I'm guessing it's 1 year or 1 month, I'm not sure. So it's y equals mx, m times x plus b. B is our intercept. Plus intercept right here, click enter. Perfect. So now all we have to do is continue for the rest of the linear trend, and we would start by, since we already did the first one, all we have to do is grab this little cross and bring it all the way down, and there you go. Okay, we click enter. So what happened here? Okay. Okay, I see what happened. We'll click right here. Yeah, something is happening. Let me pause real quick and see what is happening actually. Alright, thank you guys. Let's see what's happening. So what I had to change was that I anchored the slope, the slope, but I did not anchor the intercept. So I anchored now the intercept, and we should click enter and just bring down the cross all the way down. And there you go. Since we want to keep the same color, all we have to do is go here and go to painter. Okay. There you go. So it's the yellow again. And now to the 3 period moving average, which should. So now we have to find the absolute error. Luckily, Excel just provides us by clicking equal sign and the ABS function. So what we would have to do is subtract the demand with the linear trend to see the um, absolute error between the demand and the linear trend. Once you do that, you could click enter, and this would be the absolute error. So we would just scroll it down. There you go. So that would be our absolute errors for our demand to our linear trend. As you can see, it's increasing. And now the next thing that we have to do is actually, now to find our squared error, explains itself. We would just click the equal sign and we would just square the absolute error by shift 2. That squares our absolute error, and we just bring down the cross all the way down, and it does for the rest of us. So now to find the absolute percentage error. Now to find our absolute percentage error, once again, the function absolute, ABS, we click tab, and we would select our absolute error 2.82. And since we have it in order, we could divide that by our demand, which is 31, and click enter. We could scroll down the cross, and there you go. Perfect. So now our next step would be, so to get the 3-period moving average, we will copy the demand, right? We will copy the demand and we will go to our template, our moving average template, and we will paste the demand on the values column, and then we would put the number of periods to average. The number of periods says right here, 3-period moving average. So we put 3 here, and bam, it will give us this. Now we will copy this and paste it into our 3-period moving average on question number 7. Since for you to get an average, you need 3 periods. That's why this one's blank, because there's not 3 periods behind it, or this one, or this one. Now this one has 1, 2, and 3 periods behind it. That's why it's able to give you a 3-period moving average. And so does this one, so does this one, so does this one, so does this one. Now these don't, so we could leave those in blank. Do you hopefully you guys understand why the other ones are blank. It definitely needs a 3-period before that demand for it to give you an average of 3 periods. Now to find our absolute error for the 3-day moving average, we will use our formula of ABS. Okay, ABS, and we will get our demand minus this. Yes, it's blank now, but remember we're gonna drag the cross all the way down, and we'll get the results for the other demands. So right now it gives us no value, but we will bring it down. So it's 1, 2, 3, 4, 5, 6, and 7, and you see that it starts giving us value after an absolute error after the 3rd period. So yes, and now we do the same that we did here for the squared error. We just basically grab this and square it, and we bring it down, enter. So we could bring it to the hundreds. Let's see, we don't need all those decimals, and perfect. 13, where did it go? All right, so basically all we have to do now is, okay, the ABS function. Right. Actually, we have to go here. The ABS function. Okay. And we will get the demand of 52 divided by 34. Bam. And okay, perfect. So to get our exponential smoothing with alpha 0.2, we'll go to our template and we would have to copy our demand. Okay, copy. And okay, perfect. And for our alpha, we will put 0.2, enter, and bam, we got our exponential smoothing. Perfect. So now we would have to go back to our question number 7. Well, actually, not really. We have to. So now to make the absolute error for the exponential smoothing, we'll just get our actual demand minus our smoothing. Click enter. Oh, what happened there? Okay, it equals 0. Yeah, I'm sorry about that. 1, 2, 3, 4, 5, 6, 7. Perfect. And the squared error, once again, it would be the ABS. Oh, wait. Did I click ABS? No, I did not. Sorry about that, guys. Excuse myself. So we have to remember to put the ABS function. I'm sorry it's late at night and I'm already tired. So click here, minus here, enter. 1, 2, 3, 4, 5, 6, 7. And we'll just do ABS again. Perfect. Alright, and now for the absolute percentage error, we will ABS, whoa, ABS, select our error, and divide it by the actual demand. Click enter. And we'll just scroll it all the way down. Perfect. And that is our absolute percentage error for exponential. So now for part B of question 7, it says to calculate the mean absolute error and the mean absolute percentage to compare the 4 different methods. So for a linear trend, we'll click here, equals, and it says mean, and whenever you say mean, it means average. So you click average, and make sure it's our linear trend. You click right here, enter, and then it says the mean for the absolute percentage error. So no, I'm sorry about that, guys, it's average. Okay, and then here, enter. So that is our means for both the deviation and the percentage error. Now for the 3-period moving average, same thing. Actually, am I even recording? Yes, I am. Okay, so for the 3-period moving average, we would have to do the same thing. Oh, actually, see, we're doing our things correctly. Hmm. Okay. So we'll click here, we click average. Now we go to our 3-day thing, absolute error, click enter, and negative. Alright, so it's negative, it shouldn't be a negative. I don't know why it's saying negative. Let's see something. Okay, so we don't count the blanks, we count these. Perfect, and then for the same thing, for the percentage, and 17. Perfect, we have it right. Same thing for this. The average for the exponential smoothing, that we have it labeled right here. Click right here. Yes. Is this for absolute error? Mean absolute deviation, yes. Here. And then once again, average for the percentage. So it's 17.9. So I had a feeling that it wasn't like that. I wonder if, let's see something else. There you go. That is right. So now it says which of the four methods is better using the MAPE as criteria, which so it's asking us which of the four methods is better using the MAPE as criteria. So basically the absolute deviations, these cells right here, it shows our basically in a way our mistakes or how I would say our deviation from the exact matches. So as you can see here, it says it's 10% with the linear trend and 17% with the 3-period moving average, meaning the linear trend is more exact. So we will choose linear trend. We're not even gonna look at the exponential smoothing because look at how high these percentages are. Let's see if that is right. And yes, it is linear trend. Perfect. Now it says to create a line. Now we're gonna go here.